Hello. So the last video I did, I looked at linear sequences and finding the nth term of a linear sequence. That meant that to get from each term, you were just adding or subtracting the same amount each time. If we start by looking at these two sequences, just to illustrate a point, if I look at sequence A, just the same as what we were doing last time in the last video, the difference here is the term-to-term rule is add 5. To get from one number to the next in the sequence, we're adding 5 each time. So if n is 1, 2, 3, and 4, because the sequence is increasing by 5 each time, writing out my 5 times table, 5, 10, 15, and 20. And then each time to get from the number that's in my 5 times table to the original number in the sequence, in this case, we are taking away 2. So that is a linear sequence. Sequence B, although sequence A and B look the same, sequence B is slightly different because once I start, if I start by finding what we're doing each time to get to the next term, you'll quite quickly see that this difference here, unlike over here, is not the same. If you ever get a question like this, what you need to do, we call this one the first difference. I'll get from one number in the sequence to the next. If the first difference is not the same, you then need to find the differences between the differences, and we call this the second difference. So each time here, the difference between the differences is I'm adding 8 each time. Now, because the second difference is the same, that tells me that this would be a quadratic sequence. And what that means is that it's going to have an n squared in it, and it's not going to have anything bigger than a squared term. So for example, it wouldn't have any n cubes or n to the power of 4s. The highest power of n in that nth term would be n squared. Okay. So I'm going to show you, we're going to start with a few examples, but before I do, there's just, as with the previous videos, I've listed a few areas that you need to be able to do to be able to access this work. If you're not confident with these things, I really suggest you have a look at them, otherwise you might find yourself getting a bit confused during this video. So, this question here is the same as this sequence B here. So the first thing I want you to do with a sequence, as you were doing before, is you're just going to find the first difference. So this time we're just adding 12, that's add 20, and then that's add 28. That's my first difference. Then as before, because the first difference isn't the same, we're now going to find the second difference, which is the difference between the differences. So that was plus 8. And that was plus 8. Okay, now whatever this number is, you're gonna half this to find the coefficient of the n squared. So because the second difference is the same, it's 8 in this case, this tells me my sequence is going to be related to 4n squared. So if n is the number in the sequence, the term number in the sequence, not the actual negative 5, 7. Negative 5 is the first term in my sequence, 7 is the second term. If those are my n values, what I suggest you do first is work out what n squared is. Again, we're going to line these up. So underneath the 1 and the negative 5, we're going to square n. So n is 1, so 1 squared would be 1. N is 2, so 2 squared would be 4. N is 3, so 3 squared would be 9. And when n is 4, n squared would be 16. We are then going to, because this means here, there's an invisible times in there, so 4 lots of whatever n squared is. And we've just worked out those n squared, so all I'm going to do is times the number above it by 4. So that's going to be 36, and that's going to be 64. Okay, now you'll notice that this 4, 16, 36, 64 is not the same as the sequence. So what we're now going to do is we are going to subtract these values from each term in my sequence. So I'm going to do -5, take away this take away 4, that's going to give me -9. 7, take away 16, gives me -9. 27, take away 36, gives me -9. And 55, take away 64, gives me -9. These numbers are all the same. So because those numbers are all the same, this one's a relatively straightforward one. My nth term rule is just going to be 4n squared, take away 9. And you could always check this in the original sequence as well. So when n is 1, 4 lots of 1 squared, so 1 times 1 would be 1, times that by 4 is 4, then we take away 9, and that gives me my -5. So that one works nicely. Okay, let's try another example, getting slightly more tricky. So once again, always start by working out the difference between the terms, the first difference. Now again, because those first differences are not the same, we are then going to work out the second difference, the difference between the differences. And this time, we're just adding 2 each time. So we're going to half this number, and that tells me that it would be 1n squared. But remember, in maths, we don't need that 1, it's just n squared. So once again, when n is 1, 2, 3 and 4, all I'm going to do is square those numbers. So 1 squared is 1, 4, 9 and 16. Again, make sure you line everything up. We are now going to take away this 1 from this 5, this 4 from this 12. So 5 take away 1 gives me 4, 12 take away 4 gives me 8, 21 take away 9 gives me 12, 32 take away 16 gives you 16. Now, unlike the last example, once you've taken away the squared bit from the original sequence, these numbers are not the same. So what you are now going to do is, this is a linear sequence, and you'll see why in a second. You're going to work out the nth term of this linear sequence. So that we're going to treat as a separate sequence. Each time here, we're just adding 4. Now remember, with a linear sequence, when the first difference is the same, that just tells me what times table it's related to. So this bit here, because it's the same, this is just your 4 times table. So if I wrote out my 4 times table, 4, 8, 12, 16, you see I don't actually have to add or take away anything to get to here. So this sequence, the nth term of this sequence, is just 4n. Therefore, if we put those two things together, so I'm talking about this bit here, the squared part, and this part here, the nth term of this sequence is just going to be n squared plus 4n. Again, it hasn't got the powers of n in there go up to 2. It isn't anything higher than 2. So that tells me it's just a quadratic sequence. Okay, 2 more examples. As always, start by working out the first difference. So this one here, we're adding 15 to start with, then we're adding 19, and then we're adding 23. So first difference isn't the same, work out the second difference. Each time, plus 4, plus 4. This tells me the sequence, if we half these numbers, this tells me the sequence is going to be related to 2n squared. So let's start by working out what n squared is. That's just the square numbers, 1, 4, 9 and 16. So 2 lots of n squared, 2 times whatever n squared is, would just be double that number. Okay, now what we're going to do is we're just going to take these numbers away from the original sequence. 18 take away 2 gives you 16, 33 take away 8 gives you 25, 52 take away 18 gives you 34, 75 take away 32 is going to give you 43. Okay, so now we're just going to find, this is a new linear sequence. And as before now, we're just going to find the nth term of that linear sequence. Do this bit in a different colour. So, each time here we are adding 9, which tells me it is related to the 9 times table. So I'm going to write out my 9 times table underneath here. 9, 18, 27, 36. Now I still haven't got, if I did 16 to get from 9 to 16, from 18 to 25, and for each of these I'm actually having to add 7 each time. Therefore, if I colour code this bit, my sequence is going to be 2n squared plus 9n plus 7. And once again, you could always check it in an exam. Take one of these values, either 1, 2, 3 or 4, substitute it into here and see if the correct term comes out. Okay, last example. This one is slightly different. So, this is why I said at the start that to be able to do these sorts of questions, especially this last example, you need to make sure that you are okay with simultaneous equations. With some of the more tricky GCSE questions, you might have noticed that it brings in other areas of maths, and this is one of those times, this is one of those examples. So, we are just told that the sequence is in the form an squared plus bn. So there'll be a number before the n squared, that number is represented by a. There'll be a number before the n, and that number is represented by b. There is no number on the end, like there was in the last example where I had this plus 7. That's not going to be the case here. We are told that the second term is 16, and the fifth term is 85, and we're asked to find the values of a and b. So, if I just draw out 5 blank spaces, n here is my first term, my second term, my third term, my fourth term, and my fifth term. Remember, those are not the numbers in the sequence, that is the term number. I don't know what all of these are, but I do know that the second term is 16, and I do know that the fifth term is 85. Now, these numbers here are going to be really important for the next bit. In fact, I'll do these in different colours. So, if the sequence, the nth term rule for the sequence is in this form here, an squared plus bn, the value of n squared and n will change depending on what the value of n is. So for the second term, when n is 2, this would end up, n squared would be 4. So I'd end up with 4 lots of a. Remember, we still don't know what a is. When n is 2, bn would be 2 lots of b. So I know that 16 is equal to 4a plus 2b. Now we're going to do the same with the second value when n is 5. So if I write an squared plus bn out again, this n squared bit would come out as 5 times 5, which is 25 lots of a. And then when n is 5, this bn bit would come out as plus 5b. So I now know as well that 25a plus 5b is equal to 85. This is where the simultaneous equations come in. So taking the first one, 4a plus 2b, we know that is equal to 16. And now we're going to do 25a plus 5b is equal to 85. Now, this isn't a video on simultaneous equations, but you do need to remember that when you're adding or subtracting with simultaneous equations, you want either the coefficients of the a's or the b's to be the same. In this case, they're not. I'm going to call that equation 1 and that equation 2. So I'm going to make the b's the same. In order to do that, the lowest common multiple I can think of with 2 and 5 is 10, so I want to make the b's 10. In order to do that, I need to multiply equation 1 through by 5. So I end up with 20a plus 10b is equal to 80. Remember to multiply the 16 by 5 as well. And we're going to call that equation 3. Now I'm going to do equation 2. Remember, I want to make this bit 10, so I'm multiplying the whole equation through by 2. So I end up with 50a plus 10b equals 170. I'm going to call that equation 4. Now, once you've done that, remember the whole point of doing this is to eliminate either the a's or the b's. So to do that, I'm going to do equation 4, take away equation 3. You could do the other way round, but then when you'd end up with negative numbers, and that's another area where you could make a mistake. So try and avoid those where possible. So equation 4, take away equation 3. 50a, take away 20a, gives you 30a. 10b, take away 10b gives you nothing. And 170, take away 80 is going to give you 90. So now that we know that 30 lots of a are 90, therefore a has to be 3. Okay, that's the first bit. We found out what a is. We are now going to use that value to find out what b is. So I'm going to substitute a equals 3 into either one of the original two equations. Don't use your equation 3 or 4. I would suggest using either 1 or 2. Now, to me, equation 1, because it's got lower numbers, looks easier to work with. So I'm going to substitute into equation 1. Let's just write out equation 1 again. And now we know that a is 3, we can actually fill in some extra information here. So 4 lots of a would come out as 12 plus 2b is equal to 16. If I then take away 12 from both sides, I'm going to end up with 2b equals 4. And then dividing both sides by 2, that's going to leave me with b equals 2. So if I go back up to the original equation, I've just found that a is 3 and b is 2. So a equals 3 and b equals 2, which means if I was to write it in this form, the nth term rule for this sequence here is going to be 3n squared plus, not bn, plus 2n. And again, you could always check it by taking either 2 or the 5, substituting that in and seeing if that works. Okay. So, I have made another one of these question generators, which I will attach a link to of some sort. So, as always, you can get new questions, you can get answers on their own, or you can get all of them at the same time. If you want to try them in a particular type of question, just the first example, for example, you can just click type 1 on this little drop-down menu here. Or if you think you've got the hang of all of them and just want to try mixing them up a little bit, where I don't tell you what type of question it is, you can try these ones. If you are feeling really confident, I haven't done any examples on these today, but you can include negative coefficients. So this will be something where you might get negative n squared plus or minus something. But yeah, I'll attach a link to that file so you can get some practice as well. That's it. Thanks very much for watching. I hope it was useful. Bye-bye.